a second example for the law of cosines. In this particular example, I want to know what this side over here is. So I'm going to call it, let's call it P, just to be weird. We want to find little pineapple. Notice with the given triangle that I have a side, angle, side relationship. This is screaming to use the law of cosines. I can't use law of sines because I don't have an angle and its opposite side. So I would start off with the law of cosines, and for this example I only want to find the value of this missing side. So what I can do, I'm looking for this side, I'll say little p squared is equal to, here's my two given sides, 14 squared plus 25 squared minus twice the product of these legs, 2 times 14 times 25 times the cosine of that angle between, which would be 19 degrees. Now to find this missing side, something I want to always go back to here, I know that the value for the length of side P has to fall somewhere in the range of this sum and difference of the two known sides. So we'll start with a difference. 25 minus 14 is 11. And then I'll add it. 25 plus 14 is 39. This third side has to be a value somewhere between 11 and 39. As I'm using this formula, I simply grab my calculator and I'm going to type in what I've established there. 14 squared minus 25 squared. I'm almost, oops, should be plus. I'm almost ashamed to do that. You guys are supposed to know your squares. 196 plus 625 minus 2 times 14 times 25 times cosine. As I've said, always check, make sure you're in degree mode, that you match what you're working with. 19. So I got my cosine 19. Now I'm getting this answer of 159.136, so on and so forth. But I told myself my answer has to fall somewhere between 11 and 39. The reason why this number is so large is it's p squared, it's not p. So I've got this p squared equaling 159.1369 ... change. And I'll have to root that. And so what I'll do is go second square root that value. As I root it, I'm getting little p is equal to 12 we'll go 2 decimal places, 0.61. 12.61. And then that jives with what I was saying. I expected a side value, side length, to be somewhere between 11 and 39, and it is. So to find that side, I used the law of cosines, established this. Once you have the three sides of the triangle, well, there's all kinds of things you can do. You could find the area using Heron's formula. You could find the angles, as I did in the introduction, by using the law of sines, because now you have a side here. You could do that ratio, sine of an angle to the side is equal to the sine of an angle to the side. You could actually find the missing angles. That's your second example for the law of cosines.